Okay, so welcome back. This is the second video that is covering the first worksheet for CS120. This is for people doing just computer science, so it's the worksheet about Morse code. In the previous video we covered converting a character into its Morse code equivalent, and then we wrote a function that converted an array of characters into an array of Morse code equivalent. Since then I've just made one change, and that is I've added a new array called Morse space, and I've changed my char to Morse function by adding an extra case here. This is just because it would be useful for us when we're decoding the Morse to differentiate between a space in the string that we've entered and a character that we don't understand. Just means that if I run this, so we're going to give, oh no we're not, we're going to try and convert hello world into Morse code. So if I run this, then you can see it's done the conversion, but instead of a question mark that we were getting last time, we're getting a space. So that's the only difference in my code since the previous video. I've also realized that I say the word so about 40 million times an hour, and I'm going to try to cut down on that. Sorry. Section 3.1 then is to produce a program which will print to the serial port the character for its hard-coded Morse representation. It then goes on to explain how you can't really use a switch statement, and that we can use something called strcmp, which stands for string comparison. And yeah, okay, so we're gonna do that now. Right. The first thing we need to do is we need to write a function called morse to char. We've been given, again, the sort of function outline, so it should return a character, should be called morse to char, and it should take a pointer to Morse code, yeah. So the idea is that we give this function an array containing a bit of Morse code, and it will take that Morse code and convert it into a character. So the way we did it the other way round, the way we converted a character into Morse code, if you remember, is with a really big switch statement. And we can't switch on an array of characters, it doesn't work. What we're going to do instead is we're going to use strcomp. We're going to compare strings. And this is actually quite simple. It sounds maybe a little bit complicated, but it really isn't. If we write an if statement, we use strcomp, and we give it two parameters. We give it two things to compare against each other. So the first thing we could give it, for example, is Morse A, and we could give it the Morse code that's been passed to this function, so Morse. Now, if these two are the same, so if the array containing Morse that we pass to this function is the same, contains the same things as the Morse A array, so a dot and a dash in this case, strcomp will return 0. So that's why we have the equals 0. We're testing to see if string compare returns a 0, and if it returns a 0, it means that those two strings are the same. If they are the same, then we just want to return A, the character A. So, I see I said so again, so hard not to. If we test this, then, well, it's a little bit pointless, because all we have is a function that will take the Morse code for A and return the character A. So like the char to Morse function, we need to basically copy this a whole bunch of times. Now I've already done this to save a bit of time, so I'm just going to paste that in now. Oops. Right, so I've got a really big if-else block here, and it's not pretty, I won't lie, but this is probably the simplest way to do it. By no means the most efficient or the most elegant, but it's also fairly easy to understand. We just start at the top and we take the function has been given, so we take morse and we compare it to morse A. If it's not the same, then we go into the next statement and compare it to morse B, and etc., etc., all the way down to morse space, so comparing it to a space and comparing it to I've called morse null, which is just a question mark. This is just in case we tried to convert something to Morse code that we couldn't, as it just means that when we convert it back again into a character, we just replace it with a question mark. And I actually just need to add char morse null. Okay, so that should compile. Does it? It does. I'm just going to quickly test this. I'm just going to print out char to morse. I'm going to give it dot dash. Yeah, so that's an A. Let's give it something else as well. Let's give it a V, so that's dot 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 dash, and let's give it a J, which is, what is a J? A dot and 3 dashes. So we should get IVJ, except that doesn't compile because I called the wrong function. It's supposed to be morse to char. Whoops. Right, try that again. And look at the output. Okay, AVJ, lovely, that works. So we can convert a single Morse character into its ASCII character equivalent. And that is the entirety of section 3.1, I believe. Yes, it is. So again, we're going to move on to 3.2, which is translating a string of Morse characters into a string of characters. So this is definitely a bit more complicated. Yeah, okay. We have a function description, I guess, in the worksheet. It's void char string to morse string. Oops. It should take pointer to a character, which is the input, pointer to a character, which is the buffer, and an integer, which is the buffer size. Hang on a second. Looking at that name, it should probably be the other way around, shouldn't it? Let's call it morse string to char string, because that is actually what it does. Must be a mistake in the worksheet. Okay. We have, yeah. Oh, I've just noticed that I've got two question mark arrays. Whoops. See, easy to make those mistakes. Okay, right. Sorry about that. Let's get on with writing this function. So we've written a function that will take a single Morse representation and turn it into its character equivalent. That's called Morse to char. We now need to take a string of Morse code and turn it into characters. The way we should be calling it is Morse string to char string. We want to give it some input, so let's give it dot dash slash dot slash space dash dot dash, something like that. So that's our input, that's what we want to convert. We need to give it somewhere to store the result of that, so Morse buffer, which is our buffer declared up here, and the size is buffer size. So that's how we're going to call it. Now we need to write the actual function itself. There are a few ways to go about this. You could iterate over each character in that array, and when you find a slash, which is what separates a character, a Morse character, you could figure out how far you've gotten and do some sort of jiggery-pokery with pointers and turn that into a character. It's probably how I would do it, but there is a slightly simpler way, and that's using a function called strtoc. Now that stands for string tokenizer, and if you're not sure what that means, then a tokenizer is something that takes an input and produces tokens, and a token is a sort of sub-element of the input. In our case, this is our input, and the tokens that we want out of it are actually the Morse characters, so the dot dash, 4 dots, a space, dash dot dot dash. We want those individually. Now strtoc will do that for us. It takes 2 parameters. The first one is the array that it's going to be using it's going to be looking in to find tokens. For us, that's called input, so we give it input. The second parameter is what it uses to decide when it's found a token, so the thing that separates tokens in our array. For us, that's a slash. That's what we have in between every Morse character, so we give it a slash. Strtoc returns a pointer to a char, which is a token. So this should give us, if we print out token, serial.println token, that should give us a dot dash, which is the first token. So strtoc will look in this array here. It will say, is this a slash? No. Is this a slash? No. Is this a slash? Yes, it is. So this bit must be a token. Here, have that token, and we store that here in token. So we print that out. We look at the result. There we go. Dot dash. Oh dear, that's not what I meant to do. There we go. But obviously, there's not just one token in our string. In fact, there are lots of tokens. So what we want to do is we want to actually get each one of those tokens in turn. How do we do this? Well, this is where the strtoc function is probably going to be a little bit different to functions you've previously used. It has the ability to remember where it was and remember the fact that it's been previously called. Now that might take a little bit of getting used to, but if we call strtoc again, but this time the first parameter we set to null. So remember that parameter was the string that it's supposed to be searching in for tokens. If we set that to null and then we give it our slash like we did before, strtoc will remember that it previously was called. It will remember that it was previously called on this string here, so input. It will remember how far it got in that string. So in this case, we call strtoc once here, and it will return the dot, the dash, which is the first token. When we call it again here with this parameter set to null, it knows that it's already gotten this far, so it's actually going to return the next parameter. So if I print this out, or I print out token again after we've done this, we're going to get the dot, the dot dash and the 4 dots. Anytime now. Ta-da! Fantastic. What do we do now? Well, obviously we don't just have 2 tokens, we could have any number of tokens. So what do? Well, we're going to need a loop. And we're going to have a while loop. So why have I just written while token does not equal null? Well, we want to continue getting tokens, or trying to get tokens, using strtalk, as long as the last token that it returned was not null. And strtalk will return null when it has finished getting tokens, or it's run out of tokens to give you. For us, this means it's gotten this one, it's gotten this one, it's gotten this one, it's gotten this one. At this point, there are no more tokens left. If we call strtalk again and give it null as the first parameter, there are no more tokens, and strtalk will return null. Therefore, token will be equal to null, and therefore we will break out of this loop. So we now have a loop that will return us each token individually. If I just put this print line here, then if we upload it, we can see this in action. So we should get a h space whatever dash dot dot dash is x. So a h space x is what we're hoping to get out. Does it work? No, that's because we've not done the conversion yet. Whoops. Well, we can do the conversion because we've already written the function. So we've now got individual Morse characters, but we want the actual letters represented by those characters. And we've already written the function. It's called morse to char. Oops. So if we give morse to char that bit of that token, and that token is 1 Morse character, then it will convert that into a letter and we print that out. So I'll upload that again, and this time we really should get a h space x. Lovely, we do. Almost there. We now, instead of printing it out, we want to store those characters in an array. What array? Well, this one, the buffer. Now we can do this. Well, actually, you might think that we could use strcat to do this. And it's not a ridiculous thing to think, but you would be wrong. And the reason you are wrong, let me just try this out. So you might think that we could concatenate that character to the buffer. And if we go and compile that, it will not compile. So it will say, as you can see, invalid conversion from char to const char. strcat works with strings. So you have to concatenate a string to a string. Morse to char returns just a character, so it will not work, it will not compile. How do we do it then? Well, we know the buffer is an array, so why don't we manually insert our characters where we want? All we need is a counter, which we'll set to 0 to start off with. And we can now say that buffer position counter is equal to morse to char of that token. If we just increment counter, then next time around the loop we'll store the result of morse to char in a different location. I'm just going to run through that very slowly, hopefully make it a bit clearer. So we call morse string to char string. This is the string that we want to be translated into letters, characters. So we enter this function and we say, or we call strtalk on this input. So we call strtalk on this input here, and we say get me the first token, and the tokens are divided up by a slash. So it does, it gets to the dot dash and it returns that, and token here will point at dot dash. We then say is token not equal to null. A little bit of odd logic there, but token is not equal to null. That is true because token is actually equal to dot dash. Okay, so now we need to take that dot dash, which is here, token, and we convert it into a letter by using morse to char. Morse to char will take dot dash, it will convert that to the letter A, and it will return it. We then store that letter A in our buffer, which was also passed to this function, and we store it at position counter, which the first time round is going to be 0. So the first position, the first element in our buffer will be equal to A. We then increment our counter, so it will go from 0 to 1, and we get a new token. So token is equal to strtalk. We give null as the first parameter, which means that it will get the next token from this string here, and we're still looking for slashes. So token is now going to equal dot 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 dot. We go up again while token does not equal null. Well, token is still not null because token this time around is dot 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 dot. So now we convert dot 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 into a letter, which is H. We store that in buffer position counter. Since we've incremented counter, counter is now 1. So the second position in our array is now an H. And we go around, so the next character is a space, and then the next one is an X, I think. If we print out buffer, we should get A, H, space, X. Let's just see if that works. There we go, fantastic. And really, that is all there is to that function. If we want to be really safe, then once we've finished adding characters to the buffer, we should add a null terminating character. This just means that any functions that are string based or to do with strings and will use our array as if it were a string, they will be looking for a null terminating character to decide where the string ends. If we don't put it there, then odd things might happen. So really we should say that buffer counter is equal to the null terminating character, which is \0. If I upload and run this, there should be no difference from the previous time that I ran it, but it should be a little bit safer. Fantastic. We've now finished morse string to char string because it will take in a string of morse and it will return, sorry, it won't return, but it will convert that string of morse into letters and put them in the supplied buffer. Why do we have buffer size? Well, really we should also be checking here whether there's space in our buffer for the character. I'm not going to do that this time around because, again, this video is intended to help people that are a little bit stuck. So I don't want to complicate things. So I might come back and do some error checking later. Moving on, section 3.3, 3.4, 3.5, 3.6. These are all ways of making this code more efficient. These are ways of looking up a character from the morse, or looking up morse given a character more efficient. Task 3.4, yeah, I'm not going to go into these. Realistically, if you're at the stage where you're happy to go and do sections 3.4, 3.5, 3.6, you're probably not having too many problems. Like I said, I might come back and look at those sections in more detail in another video. We're going to go straight on to section 4, which is the last section in this worksheet. Section 4 is about flashing an LED, so actually flashing Morse code. Section 4 says that we need to write another function, and this one's going to be string to Morse flash. The idea of this is that we give it some text, for example, hello, and the LED will flash the Morse code for hello. Before we can start doing that, really we need to set up which pin we're going to use as our LED. I've just got a plain Arduino board, I don't have any shield with me, but the Arduino does have an LED on the actual board, which is on pin 13, so that's the pin that I'm going to be using. Before we can use that pin to flash lights or anything else, we need to set up the pin mode. Pin mode takes two parameters. The first one is the pin we want, so for me this is 13, for you, although the worksheet says 13 as well. Okay, so it's 13. And we need to decide whether it's an input or an output. Well, as we want to flash a light, it's definitely an output. The reason that we have to do this is that if we don't set the pin mode explicitly, we have no idea what state that pin is in. That pin might be an input still from a previous program, or it might be in some odd undefined state. By setting the pin mode explicitly to output, we know that that is going to work, and it means that when we try and set the output high or low, it's actually going to do what we think it's going to do. Okay. Void. Let's go for jar string to Morse flash. It should take a pointer to a jar, which is the buffer. It should take an int, which is the pin, and an integer, which is the dot length. So actually, this pin mode here could go inside the char string to Morse flash, and we're going to replace 13 with pin. This just means that we could, when we could call this function, we could give it a different pin if we wanted, if we had an LED connected to a different pin. Dot length is how long a dot should last, and all the other units of time in Morse are based off of how long a dot is, so that's all we need. Okay, first things first, we need to take our string of characters, which is going to be stored in buffer, and we need to convert them into Morse code. Well, we did this in the last video, and it was a function called string to Morse string. So we can use that in this function here. So let's call string to Morse string. That takes an input, in this case buffer, because that's what we want to convert into Morse code. We need to give it a buffer to actually fill with Morse code. And again, we've already defined one up here, char Morse buffer. So I'm going to give it Morse buffer, and we need to give it how big the buffer is. And we've got that buffer size. So now we've taken the string of characters and we've used string to Morse string to convert that into Morse code, and that's stored in Morse buffer. So if I call this function, so call char string to Morse flash, we say hello world, we say pin 13 and a dot length of 100 milliseconds, let's say. I print down here Morse buffer. This is going to upload that. We should get the Morse code equivalent of hello world printed out to the console. And we do. Lovely. Now we need to take the contents of that buffer and flash the LED in different ways depending on what the character is and whether it's a space or something like that. So we want to get rid of that print statement. Before we do that, we should work out how long all the delays need to be. We have how long a dot is. I'm actually just going to call this dot because it makes it a little bit nicer. So we need to work out how long a dash is. A dash, well, the worksheet right at the beginning says that a dash is 3 dot lengths, so it's going to be dot times 3. A letter space, so a space between two letters, is 3 dot lengths as well. Let's call it letter space equals, we'll just set it to, well, we can just set it to dash because dash is also 3 dot lengths. We need a word space, so word space, that's 7 dot lengths, so dot times 7. And we need a symbol space, that's the space between a dot or a dash or something like that. So symbol space is equal to dot. Fantastic. We now have all the lengths of time that we need. Next, we need to combine all of this with the Morse code that we've generated. We can work out how long that Morse code is using strlen. We call strlen on Morse buffer, then we know how big our Morse code is, how many characters are in our Morse code. We now need to loop over that. So for each dot, each dash, each slash, each space, or whatever else is in there, hopefully just those actually, we need to do a different thing. So we're going to start at 0. We're going to go to the end of our Morse code buffer, increment by 1 every time. And I'm just going to use a switch statement in here. Depending on what is in that position in the buffer, we're going to do different things. Actually, just to make this easier to explain, I'm actually going to add that print statement back in Morse buffer. Okay. We need a few cases. The obvious one is a dot and a dash. What else? Well, we need something that separates letters, so we have our backslash, and we're going to need a space, which is obviously a space between a word. Okay, that should be all that we need. We will add a default case as well, just in case. You should always have a default, but the default will not do anything. I'm just going to format that. There we go. So if our buffer, and I'm just going to run the Arduino again. Right. This should hopefully help explain it a little bit better. So this loop here is looping over each one of these characters down here, which is in Morse buffer. When I is 0, we're going to get the first one. That's a dot, so we're going to do this case. And we're going to keep on going through it, so eventually we're going to get a slash, and then a dot, a slash, dot, a dash, etc. If we get a dot, then we need to turn the LED on for 1 dot length of time. So that's digital write. And that's the function that we use to set an output high or low. The pin that we want, so pin, and whether we want it to be high or low. So we want it to be high. We now need to wait for the right amount of time, and because it's a dot, we should wait 1 dot. Right? We now need to turn the LED off. So we set pin to low. I should turn it off. And we need a break at the bottom. The reason that we have this break here is that if we didn't, if this case were to match, so buffer I was a 0, then we would do the digital write, delay, digital write. If this break was not here, we would just go and do the next case until we get to the bottom of the switch statement or we find a break. So the break means do all of this in this case and then break, so it will actually go from here out and it will exit the switch statement. Not putting in a break when you meant to is the source of many bugs, so keep an eye on that. If we get a dash, then the same procedure. I'm actually just going to copy this. Except we want to delay for a dash amount of time, and actually something I forgot here is that we need to actually delay after we've flashed our light. For a dot we need to delay again, and that delay is the symbol space amount of time. And this just means that when we're transmitting Morse code, there's a space between a dot and the next dot, or the dot and the next dash, or the dash and the next dot. And we need to have that for a dash as well. Okay. Now we need to handle a slash. Now a slash is a separator between two symbols, or not two symbols, but two Morse letters. And all we need to do here, we don't need to turn the LED on or off. We actually just need to delay, and we need to delay for a letter space amount of time. And again, we need to make sure that we put our break statement, and the space is a space between words. So again, we don't need to turn the LED on, we just need to delay for word space amount of time, and again break. I'm just going to make sure that that compiles, and it doesn't compile because I forgot to declare that. Okay, now I'm going to test something a bit more recognizable than hello world. I'm going to do SOS. Now, obviously you can't see my Arduino, but I'm going to run it now and I'm going to see if that works. Hopefully it does. Okay, that does seem to be working. I'm just going to slow down the flashing a little bit. Dot is going to be, say 250 milliseconds. It just makes it a little bit easier for me to see whether I've actually got it right or not. I just noticed that I had a bug, and I didn't notice. I'd previously called a switch on just buffer, which was a mistake because that's not what I wanted to convert. So I meant to call switch on morse buffer, which is the actual buffer that contains the morse code that I generated using the characters. So now it definitely works. There we go. That is the whole of worksheet 1. I will maybe, if I get time, do another video where I do tasks 3.4, 3.5, 3.6. No promises though, and I might also look at some of the error checking in a bit more detail, because things like Morse string to char string, they take the buffer size as a parameter, so really we should use that to make sure that there is space in our buffer to add the next character. But like I said, this video is just intended to help people who are maybe a bit stuck, so it's just trying to keep it as simple as possible. I hope this has been useful to you. If the general consensus is that it has been useful, I will try and find the time to make some more videos for other practicals and other worksheets.